Good morning, everyone. Today I will tell you about quantum information science.
Quantum science and technology is really the ongoing revolution. And in this field, Tony Acín is really the star.
The main goal of quantum information science is to understand how quantum physics will allow us to change the protocols we have today for information processing and communication.
His achievements in quantum information are very well known. The 2 subsequent ERC grants, several papers in the top journals, impact in the community which is really enormous.
Using quantum physics, we can make quantum cryptography. This allows two parties who want to exchange private information to do it with a much stronger security than any classical existing scheme.
Tony is an expert on quantum information, so I have the pleasure to collaborate with him since he was a very young student. We worked and wrote together several papers, and in particular one we solved a prominent problem at that time, which was to prove mathematically that it is possible to encode information such that nobody else can decode it.
In fact, quantum cryptography is the most mature quantum information technology. Today you can buy quantum cryptography and use it to secure your information exchange using quantum physics. It was a surprise when some years ago some researchers hacked quantum cryptographic protocols. How come? How this is possible?
He always chooses a problem which is very simple to formulate and even very simple to understand by laymen. And then, despite this fact, the problem is very difficult, but Tony solves it.
There is a mismatch between what the theory needs to prove security and what you do in the lab. So the hackers didn't break the principle, but they broke the implementation.
He has a tremendous inventivity. He's really able to drive many students in different fields all at the same time and all successfully. Extremely respected.
The device-independent approach offers a solution to the hacking attacks. In the device-independent scenario, devices are just seen as boxes that process classical information. This is a very minimalistic and abstract scenario. As the devices are boxes, there cannot be any mismatch between what the theory wants and what you do in the lab.
People keep coming back after meeting him, so people like to be working with Tony. He has very good ideas. He's very good at giving you the correct balance between direction, and on the other hand, it gives you freedom to research.
The device-independent approach will bring quantum cryptography to a much higher level of security, in which all these hacking attacks will become impossible.